Hello Algebra 2 students, this is your Unit 5 review. Remember to try these problems first and then go back and watch the video only for the problems that you find confusing. And remember to pause the video every once in a while to see if you can finish the problem without any help, and then go back and check and see if the video confirms your work. In problem 1, we're trying to determine whether w minus 2, let's grab a pen, whether w minus 2 is a factor of this polynomial here. And a binomial will be a factor if it divides evenly, so you're checking to see if the remainder is 0. So you can divide this with long division or with synthetic division, but usually synthetic is the quickest way to go. So if w minus 2 would be a factor, then you want to set w minus 2 equal to 0 to find out what number goes in the box. When I solve this, I get w equals 2, so 2 goes in the box. The coefficients come next, and I'm checking to see if I'm missing any terms. I have 4, 3, 2, 1, and none, so I'm not missing any terms. I don't need any 0 placeholders. My coefficients are 1, -1, 2, -4, -8. Okay, the pattern for synthetic division is multiply, add. So after you bring down the very first number, you just continue with multiply, add. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -4 plus 8 is positive 4. 2 times 4 is 8. -8 plus 8 is 0. Remember, in synthetic division, this last number is your remainder, and because your remainder is 0, you can make the conclusion, yes, w minus 2 is a factor, because when I divide, the remainder is 0. Okay, next we have some factoring problems. Alright, the first one has 4 terms. Always check first to see if there's a common factor we can take out, but it looks like not all the terms have x, and they don't have any number in common I can divide them by, so we don't need to do a common factor. Next, because it's 4 terms, I'm going to try factor by grouping. So you need to split the 4 terms in half, and you're going to look for a common factor from the first 2. So 2 and 10 can both be divided by 2, so I'm going to take the 2 out. And they both have x's. They both have at least x squared in them, so I'm going to take x squared out. So now I have to think 2x squared times what would give me 2x to the third, and that would be x to the 1, plus 2x squared times what would give me 10x squared. That's 5. So now if I were to multiply this, I would get what I started with. The second 2 terms are both negative. If the lead term's negative, I always want to take a negative out. And they can both be divided by 9. So I'm taking -9 out. -9 times what gives me -9x? That's an x. -9 times what gives me -45? That's a positive 5. So when you factor by grouping, if you get the same inside the parentheses, you know you're on the right track. That's one of your factors, x plus 5. X plus 5 is being multiplied by 2x squared and also by -9. So that makes your second factor. Okay? If this were just x squared minus 9, we would continue factoring the difference of squares there. But because of the 2, This term's no longer a perfect square, so we're done with factoring. Alright, in this next one, it looks a little bit complicated because we have two different variables. So if that kind of makes this seem unreachable to you, you can try thinking about a simpler problem to start with. What if we just got rid of the y's and we thought about x squared minus 5x plus 6? So thinking about that for a moment, you think, okay, I need numbers that multiply to 6 and add to negative 5. And those numbers are negative 2 and negative 3. So without the y's, I would have x minus 2 and x minus 3. But I need something to give me this y squared at the end. So if I were to put a y here and a y here, now I see negative 2y times negative 3y gives me positive 6y squared. And let's check and see if the middle term works out too. If I multiply these two, I get negative 2xy, and if I multiply these two, I get negative 3xy, which together makes the negative 5xy, so we figured that one out. Alright, the last one, this cube here, is a clue that I have difference of cubes. So what you want to do is you want to find the cube root of 27 and the cube root of 125, and if you can't do that in your head, you could use your calculator. So if you press the math button, cube root is a choice. It's number 4. Cube root of 27 is 3. And let's do 125. Cube root 125 is 5. So those are the numbers we're going to be using. So 27 could be rewritten as 3 to the third, and this whole term is 3x to the third. 125 is 5 to the third. So then you need to remember your cube's pattern. For some of you, it helps to remember SOPs. It starts a cubed minus b cubed. Starts with a minus b. And then it's going to be a squared plus ab plus b squared. So you notice here that this is a cubed minus b cubed. We have the cube of 3x minus the cube of 5. So everywhere we see a, we put 3x, and everywhere we see b, we put 5. Let me connect those for you. 3x is the a, 5 is the b. So instead of a minus b, I have 3x minus 5. And then I have the square of 3x. Be careful, you have to square both the 3 and the x. And then a times b, so that would be 3x times 5. And then the square of 5. So these are our factors, but we can probably simplify this second one just a little bit. So I have 3x minus 5. The square of 3 is 9, so this is 9x squared. This term becomes 15x, and the last term is 25. Okay, let's move on to the next section. We are talking about transformations. This is a review from much earlier in the year, but every function that we graph can be transformed with transformations. So we need to remember these. If you have a negative, the negative is going to reflect across the x-axis, so that anything that is up here would be down here. So the negative reflects across the x-axis. Okay, the x minus 4 is a tricky one because remember that anything that happens to the x happens inversely, so that instead of going left 4, you're actually going to go right 4. And the plus 5, that happens to the y. And so that one happens exactly as you see it. It's going to go up 5. Remember that translate is the same as shift. All right, let's look at the second one. The second one has a 2 and a -3 that are happening to the y. And I can tell they're happening to the y because they're not in the parentheses. So anything that happens to the y happens in the up-down direction. The 2 is a stretch. So we're going to say stretched. This way is vertically by 2. And then shifted, the -3 is the up-down, so that's shifted down 3. Or translated. I'll use translated to be consistent here. Down 3. And then remember that anything that happens to the x happens inversely, so we're going to translate to the left 7. Okay, let's turn the page. All right, we've seen this polynomial chart before, so we're going to review this again as well. Remember that the number of turns is 1 less than the degree. So the turning points are here, here, and here. And it's important to actually note what those turning points are so that we can use them when we do increasing and decreasing intervals. So this first turning point is 1, 2, 3, 3.5 back, so -3.5. And then it goes up 1, 2, 3, 4, 5, 6, 7. So -3.57. This turning point is 1.5, 1.5. And that last turning point seems to be maybe not on a 0.5 at all, so let's check that out. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, 5. All right, so because it has 3 turning points, the degree is 1 more than that, so the degree is 4. And the type, if it's degree 4, is a quartic. The number of real solutions, the real solutions happen when you cross the x-axis. There's one here, and there's one here. Remember that if the graph were to have bounced off the x-axis, I would have to count that one twice. But in this case, there's no bounce, so I just have 2 real solutions. The number of imaginary solutions is the degree minus the real solutions. The degree tells you how many solutions there are all together. And if 2 of them are real, that means 2 of them have to be imaginary. The x-intercepts are the same as the real solution, so let's count those. 1, 2, 3, 4, 5, 6. So -6, 0. 1, 2, 3, 4, 5, 6. Looks like +6, 0. 2, 6, 0. All right, the y-intercept is right here. It looks like it's about 2.5 or 3. Let's see. We're going to go with 3 for that one. Okay, and let's go look at the end behavior. Here's your end behavior on the left. Here's your end behavior on the right. Now on the left, the x is always going to -infinity, and on the right, the x is always going to +infinity. So this is -infinity for the x, and this is +infinity for the x. Now if these arrows were pointing up, they would be going to +infinity, but they're both going down, so both of your y's are going to -infinity. So that's negative, negative, and that's positive, negative. So usually we write the right side of the end behavior first. As x is going to positive infinity, the y is going down. So as x goes to infinity, y goes to negative infinity. And then on the left side, x is going to negative infinity, the y is going down as well. So the y is also going to negative infinity. All right, increasing and decreasing. You read a graph from the left to the right. So if I start over here on the left, I'm going up, 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 up. That's increasing. So let me choose a different color here. Maybe a highlighter, a yellow. So this is increasing. All right, then I start going downhill. That's decreasing. Now I'm increasing again, up, 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 and then I'm decreasing. So my increasing intervals, you need to list the x values. So my x value here is negative infinity, and my x value here is negative 3.5. So I'm increasing from negative 3.5, nope, that's the end, sorry. From negative infinity to negative 3.5. And I'm also increasing from 1.5 to 4. So remember to write the x values. You always use parentheses for increasing and decreasing, because once you get to this point right here, you cannot include it. You're not increasing or decreasing. You're just kind of stop there for a sec. All right, decreasing intervals. Again, use the x values, negative 3.5 to 1.5. And then 4 to infinity. Okay, find all the zeros of the function. Use your graphing calculator to find the real zeros. Graphing calculator. Then use division and quadratic formula to find the imaginary zeros. So let's see what this looks like when we graph it. Press y equals and enter your equation. X to the third plus x minus 10. And press graph. Okay, there may be more zeros over here, but because these numbers are pretty small, I'm going to guess that we can see all of our zeros. And it looks like I have a zero at positive 2. If you're not sure if it's exactly positive 2, you can press second graph to look at the table of values. And yes, when my x is 2, my y is 0, so that works out. So I have a 0 at 2. So I have a 0 at x equals 2, which means I have a factor of x minus 2. So remember that if you are going to use synthetic division, it's the 0 that goes into the box. So I'm going to put 2 in the box. And then I'm going to line up my coefficients. I have 1x to the third. Notice I don't have any x squared, so you need to put a 0 in for a placeholder there. Then I have 1x, and I have a minus 10. Okay, bring the 1 down. 2 times 1 is 2. Then you add. 2 times 2 is 4. Add. 2 times 5 is 10. And then you add. Now, as you expected, your remainder is 0, because we knew that 2 is a 0. We knew x minus 2 is a factor, so we knew it was going to divide evenly. When you divide a polynomial of degree 3 by a polynomial of degree 1, remember x cubed divided by x to the 1 would give you x squared. So your result here, your depressed polynomial, is going to be degree 2, meaning this is 1x squared, this is 2x, and this is 5. Now, if we could factor this, those factors would show up as x-intercepts on our graph. So I have a hint that we cannot factor this, but you might as well try. Think of numbers that multiply to 5 and add to 2, and that doesn't work out. So we're going to do quadratic formula. Remember the formula, negative b plus or minus the square root b squared minus 4ac over 2a. So we're going to put our numbers in. A is 1, b is 2, c is 5. So I have negative 2 plus or minus square root. 2 squared is 4 minus 4 times a times c over 2 times a. Okay, so let me look at my discriminant first. 4 minus 4 times 1 times 5. 4 times 1 times 5 is 20. 4 minus 20 is negative 16. So I have negative 2 plus or minus the square root of negative 16 over 2. And the square root of negative 16 is 4i. The square root of 16 is the 4. The square root of the negative 1 is the I. So I have negative 2 plus or minus 4i over 2. And now you want to divide each part by 2. Negative 2 over 2 is negative 1. 4i over 2 is 2i. So it says to find the real zeros and the imaginary zeros. So I'm going to write a set of all zeros. The real zero was 2. The imaginary zeros are negative 1 plus 2i and negative 1 minus 2i. Okay, let's turn the page. Alright, here we have two division problems. Now remember, synthetic division is generally easier, but you can only use it if you have a linear factor with a leading coefficient of 1. So a linear factor means that we're dividing by something that's not x squared or x to the third, and the leading coefficient is 1. So this one we'll be able to use synthetic. For this one, because we have a leading coefficient of 2, we're going to do long division. So we're going to do 2x plus 3 into 6x to the third plus 5x squared plus 4x plus 19. Okay, so first we think 6x cubed divided by 2x. 6x cubed over 2x. That gives me 3x squared, and I write that above its like term, 3x squared. Now I multiply 3x squared times 2x plus 3. And I distribute, so I get 6x to the third plus 9x squared. And that goes here. Now I need to subtract both terms. So the first terms cancel, and I have 5 minus 9, so I get negative 4x squared. Bring down the 4x. Alright, now again, it's the first term divided by the first term. So negative 4x squared divided by 2x. That gives me negative 2x, and I write it above the like term here. Okay, now multiply negative 2x times 2x plus 3. Oops, too many pluses. Distribute, and I get negative 4x squared minus 6x. That goes down here. And subtract. So those two cancel. Now this is 4x minus negative 6x. Because of the minus negative, that makes plus 6x. So I have 4x plus 6x, which is 10x, and bring down plus 19. So now we're thinking 10x divided by 2x. And I get 5. So I put the plus 5 here and multiply 5 times 2x plus 3. I get 10x plus 15. And subtract, and I have a remainder of 4. So for your final answer, you want all of this, and then plus your remainder over your divisor. That's a fraction. So I have 3x squared minus 2x plus 5 plus 4 over 2x plus 3. Okay, for this next problem we're going to do synthetic division. Okay, so the 0 of the divisor goes in the box, so x minus 3 equals 0 gives us x equals 3. So 3 goes in the box. Then you put the coefficients next. The coefficient of x to the third is 1. There's no x squared term, so you need a 0 to hold the place. Then minus 5, and then plus 2. Bring down the first one, and then multiply, add, multiply, add. So 3 times 1 is 3, 0 plus 3 is 3. 3 times 3 is 9, negative 5 plus 9 is 4. 3 times 4 is 12, and 2 plus 12 is 14. So if you start with x to the third and you divide by x to the 1, your answer starts with x squared. So this is 1x squared plus 3x plus 4 plus, remember this is your remainder, so 14 over the divisor. The divisor was x minus 3. Okay, the rectangle has an area x squared plus 11x plus 24 square meters and a width of x plus 3 meters. Find its length. So remember that area equals length times width. So if we're trying to find the length, you can divide by the width, and you get that the length is the area divided by the width. So we're going to divide this area by the width. So we're going to do synthetic division, and I'm going to find the 0 of the divisor, so I get x equals negative 3. Put negative 3 in the box, and then we have 1, 11, 24. Bring down the first number, multiply, add. Negative 3 times 8 is negative 24, and add. We get a remainder of 0, and x squared divided by x to the 1 is going to become x to the 1. So this is 1x plus 8. So x plus 8 is our length, and our unit is meters. So x plus 8 meters. Alright, in 13, we're going to find a polynomial function in factored form that passes through these points. So the x-intercept points, those are going to create factors. So these are the x-intercepts because the y is 0. We're going to use those to make the factors. So if you have a 0 at 2, then you have a factor of x minus 2. And if you have a 0 of 5, your factor is x minus 5. And if you have a 0 of 1, then you have a factor x plus 1. We're going to use this value to find the a. So remember, the a is the lead coefficient. It comes in front of the factors, and then y is going to equal all of this. Well, we can plug this point in, 0, negative 30, to find what our y is. So I'm going to put negative 30 for my x, no, negative 30 for my y, and 0 for my x's. So a, 0 minus 2 is negative 2, 0 minus 5 is negative 5, 0 plus 1 is 1. Negative 2 times negative 5 times 1 is 10. So I get negative 30 equals 10a, and divide it, and a equals negative 3. So now we can write this in factored form. Y equals, your a value is negative 3, and then write your factors. X minus 2, x minus 5, and x plus 1. So that's the end of your first video. You're going to click on the second video to check the rest of your packet.